Hello and welcome to a new episode of Conquering FreeCodeCamp Curriculum Challenge. Today we're going to go to the next section, which will be Redux. Yesterday, for those of you who missed it, we learned about React, which was a pretty fun stream. It took like 3 hours, but eventually we got through. If you want to check it out, go to the description and you can find a playlist with all of the live streams we recorded. Alright, Redux. To be honest, I tried to learn, I kinda learned Redux through 2 or 3 times already, but because I haven't used it that much, I forgot. So, this is sort of a learning experience for me too, which should be fun, because I'm learning, you're learning, everyone's learning, and hopefully we'll be happier. I don't know. Hello for those of you who are joining the live stream. Hello Alex and Gulshan. And hello also for those of you who are watching the recording. Hopefully this will be useful for you. Alright, let's get into it. Redux is a predictable state container for JavaScript apps. So apparently Redux is for, we always associate Redux with React, but I think this is more of a JavaScript thing, so maybe we should keep that in mind. Yeah, so it helps you write applications that behave consistently, run in different environments, client, server, and native, and are easy to test, while you can use Redux with any view library, so you can use with other view libraries also. It's introduced here before being combined with React. So that's interesting. Alright, let's see our first challenge. Okay. Redux is a state management framework that can be used with a number of different web technologies, including React. In Redux, there is a single state object that's responsible for the entire state of your application. This means if you had a React app with 10 components and each component has its own local state, the entire state of your app would be defined by a single state object housed in the Redux Store. Okay, so this is like the big boss of your store, sort of. Hey Joy! Thank you Alex! Hey Greet! And Raj, welcome all! Alright, so Redux Store. This is the first important principle to understand when learning Redux. The Redux Store is the single source of truth when it comes to application state. This also means that anytime any piece of your app wants to update state, it must do so through the Redux Store. Alright, okay. The I can't pronounce that word. Unidirectional. Oh well, you can read it here. Look, I highlighted. Okay, data flow makes it easier to track state management in your app. Alright. Yeah, so a little off topic. Well, not really off topic. When I was working as a React developer, in the project we used MobX, which seems easier, sort of. I don't know. As I said, I tried and I did sort of learn Redux a couple of times, and it's a little confusing, so don't blame yourself if you don't get it from the first time. Not really that easy to comprehend, but with practice I guess it gets easier. Also, for what I've learned and heard is that Redux is harder to get into, but then it simplifies your work and it gets easier, so who knows. Okay, let's see the first task. The Redux Store is an object which holds and manages application state. This is a method called createStore. Not this. There is a method called createStore on the Redux object, which you can use to create the Redux Store. This method takes a reducer function as a required argument. The reducer function is covered in a later challenge and is already defined for you in the code editor. Okay, so we can see it's a function which has a state initialized with 5. Okay. Okay, it simply takes state as an argument and returns the state. Alright, so we take a state and return state. Good. Declare a store variable and assign it to createStore. Okay, so store will be createStore. Redux createStore, because we want the createStore method from the Redux library. Let's see, Redux methods are available from a Redux object. For example, redux.createStore. Define the store here. Alright. Passing in the reducer as an argument. Okay, so we need to pass in a reducer. I think the terminology is a little confusing, but maybe it's just me. The code in the editor uses ES6 default argument syntax to initialize. Okay, so basically. Alright, so we created a store and we initialized it with Redux createStore with our reducer. Alright, let's see what happens next. Get state from the Redux Store. The Redux Store object provides several methods that allow you to interact with it. For example, you can retrieve the current state held in the Redux Store object with the getState method. The code from the previous challenge is rewritten more concisely in the code editor. Use store.getState to retrieve the state from the store and assign this to a new variable, current state. Okay, let's see what they have here. A store, okay, Redux createStore, and then they pass in a function which has a state and returns state. Alright. Well, it initializes state with 5 and returns it. So now we can get the state. Use getStore to retrieve state from a assigned new variable current state. Current state will be store.getState. And let's console.log current state so we can see what's happening. Okay, we get 5. Because, well, this is initialized here. What if we have an object here? And this object has A1 and B2. Alright, you can see that basically we get the state here. Okay. It's pretty good so far. Define a Redux action. Since Redux is a state management framework, updating state is one of its core tasks. In Redux, all state updates are triggered by dispatching actions. An action is simply a JavaScript object that contains information about an action event that has occurred. Okay. The Redux Store receives these action objects, then updates its state accordingly. Sometimes the Redux action also carries some data. For example, the action carries a username after a user logs in. While the data is optional, actions must carry a type property that specifies the type of action that occurred. Hello Ankit, welcome to the live stream. Alright, so we can dispatch actions, and these actions have, they can hold receive this action update and update this state. Okay, can also carry data. Alright. Think of Redux actions as messengers that deliver information about events happening in your app to the Redux Store. Okay. The store then conducts the business of updating state based on the action that occurred. Alright, a little too many words for me, but hopefully we're going to learn better while doing the task. Writing a Redux action is as simple as declaring an object with a type property. Declare an object action, so action will be an object, and the type of login. Okay. Define an action creator. Alright. After creating an action, the next step is sending the action to the Redux store, so it can update its state. In Redux, you define action creators to accomplish this. An action creator is simply a JavaScript function that returns an action. So it creates an and returns an action. In other words, action creators create objects that represent action events. Define a function named action creator that returns the action object when called. Okay. Interesting. So we create a function to return this object. Joe is asking, what is that type? Well, we haven't learned about that yet, but in my vast, in quotes, knowledge, is this type is used to, let's see. Well, let's go and look through this one. Apparently it explains it better than I could, so keep following and we'll learn about it. Dispatch method is what you use to dispatch actions to a Redux store. Calling store.dispatch and passing the value returned from an action creator sends an action back to the store. So yeah, we learned about dispatching events. So dispatching actions. You can see here that we have a store and we can dispatch some action. Well, and this function basically will return our object. Okay. Recall that action creators return an object with a type property that specifies the action that has occurred. Okay, then the method dispatches an action object to the Redux store. Based on the previous challenges example, the following lines are equivalent. Another funny word I'm pronouncing. And both dispatch the action of type login. So yeah, we have it here. Login action returns an object with the type of login. And then we're dispatching this action to our store, which for now is an object with a login property of false. Okay, let's see. The Redux store in the code editor has an initialized state that's an object containing a login property currently set to false. Yep. Okay. There's also an action creator called login action, which returns an action, which is an object of type login. Dispatch the login action to the Redux store by calling dispatch method and passing the action created. Okay, so store dispatch our login action, and we need to call this because it returns an object. Let's see what this returns. Type of login. So it returns the action. Okay. And this, let me get it out of here. This is basically the same as saying store dispatch, and we give it an object with a type of login, right? Yeah, because basically this function returns an object. Why we need to wrap it around the function? I don't know now, but probably will handle an action in the store. Okay, so Joy, this is the part you would need to look at. This hopefully will answer your question. After an action is created and dispatched, the Redux Store needs to know how to respond to that action. This is the job of a reducer function. Okay, so that reducer function which we passed when we created the store. Reducers in Redux are responsible for the state modification that take place in response to actions. A reducer takes state and actions as arguments, and it always returns a new state. It is important to see that this is the only role of the reducer. It has no side effects. It never calls an API endpoint, and it never has any hidden surprises. The reducer is simply a pure function that takes state and action, then returns the new state. Okay. Oh, look at that. Don't have water. 1 second. Okay. Another key principle in Redux is that state is read-only. In other words, the reducer function must always return a new copy of state and never modify state directly. So basically the reducer is a pure function. We learned about this in the JavaScript section. Yeah. Redux does not enforce state immutability, however you are responsible for enforcing it in the code of your reducer functions. You'll practice this in a later challenge. The code editor has the previous example as well as the start of a reducer function for you. Fill in the body of the reducer function so that it receives an action of type login. Oh, you can see now that the state is initialized with default state, which is created above. Okay, and now to the reducer we also pass in an action. Okay, fill in the body of the reducer function so that if it receives an action of type login, it returns a state object with login set to true. Okay, so if action.type is login, we want to return a new state, which is an object, with the login set to true. Note that the current state and the dispatched actions are passed to the reducers, so you can access the actions type directly with action.type. Okay. Let's console.log our store now to see what we have on it. Okay. Dispatch, subscribe, dispatch is a function, subscribe, get state. Okay, we haven't learned about those. So, let's see, get state. We get undefined. Why? Oh, I think I know why. because we're only returning a state if the action type is login, but we don't have a default return. So let's do this. Okay, now we return the default state, but if the action type is login, we return a new state. Okay, what happens if we dispatch an action? Dispatch login action. Okay, so now that's nice. Look at that. First, our state is login false. Then we dispatch our action. Okay, we don't need to console this. We dispatch our action and then our login becomes true. Okay. Interesting. Interesting how store now it changes the state even well. Action type is login. Then returns a new state. Interesting. Okay, let's move. Okay, something's wrong. The store should be initialized with an object with property login set to false. Dispatching login action should update the login property in the store to set true. That's what it does. So what's wrong with you again? Okay. We probably called the dispatch action and it was set to true first. Alright, so now the switch statement. You can tell the Redux Store how to handle multiple action types. Say you are managing user authentication in your Redux Store. You want to have a state representation for when users are logged in and when they are logged out. You represent this with a single state object with the property authenticated. You also need action creators that create actions corresponding to user login and user logout, along with the action objects themselves. The code editor has a store. Okay, authenticated false. Then actions, login and logout user. Actions and action creators are set up for you. Fill in the reducer function to handle multiple authentication actions. Use a JavaScript switch statement in the reducer to respond to different action events. This is a standard pattern in writing Redux reducers. The switch statement should switch over action type and return the appropriate authenticated state. Alright, so let's do that. At some point, don't worry about state immutability, since it is small and simple in this example. For each action, you can return a new object. Also, don't forget to write the default case. Alright, so let's do the switch. We want to switch action.type. And we'll have case where the type is login. We want to do something. We have case where the type is logout. Right? Login, logout, okay. We want to do something. Oops. And we have the default case. Okay. In the default case, we want to return the state. So the initial, the state that currently is in. If it's logged in, we want to return a new object with authenticated saying true, right? Alright. And when we are logging out, we want to return a new state with authenticated to false. Okay, now this will work. Now dispatching user logout user should update the authenticated property false. Oh, authenticated, not auth reducer. Okay, now this should work. Let's see it in action. So first, if we console.log store.get, what method do we have there? Get state. Store.get state. We have false, which is basically the default state. Next, let's put two more. We have false, false. But if we're going here and say store.dispatch, and we dispatch an action which will be login user, now the authenticated will be true for the following true. Makes sense, right? So we're dispatching an action of type login, which will go here in our switch, and it will be case login, and it will return the authenticated through object. But if we go again and say logout user, then the last one will go back to false. Alright. Seems okay so far. I still have some questions, but let's see. A common practice when working with Redux is to assign action types as read-only constants. Then reference these constants whenever they are used. You can refactor the code you're working with to write the action types as const declarations. Okay, so we have type here like a string, but apparently they want us to create const variables. So const login will be login, and logout will be logout. Probably if the application gets bigger, you would have something like action constants or something actions, and this will be an object with login being set to login and logout being set to logout. Because this looks much better, you have everything inside actions, and then you can go here and instead of the string you can use actions.login. Also here you can use actions.logout, and don't forget here to change login and logout. I also created those two variables because, well, they require us to do, but I like this approach much better. You have everything inside actions constant. The action created and reducer should reference the login and constant. Okay. So apparently they put us to do this. Alright. So this will be best practice, probably. Okay, 50% almost. Register a store listener. Okay. So what's with that? Another method you have access to on Redux Store object is store.subscribe. This allows you to subscribe listener functions to the store, which are called whenever an action is dispatched against the store. One simple use for this method is to subscribe a function to your store that simply logs a message every time an action is received and the store is updated. Okay, so think of this as like some sort of, you step in the store and every time something happens you want to do something. In this case we want to log out the state. So when we're dispatching our actions, we want to see what happened. Okay, you can see here we have a state which is just a number in this case. We have actions, one action only, add, which returns the state plus 1. And the default returns the state. Okay. Now, we have a store, we initialize with the reducer, okay, and we have a global count variable. Right. Oh, I see. So this is what it's counted here, the global count, not the state. Alright. Write the callback function that increments the global variable count every time the store receives an action. Okay, and pass this function into the store subscribe method. Okay, so we want to write the function increment count. That's interesting because we want to play with this count. Okay, so we increment the count and then we want to pass this function to store.subscribe. Subscribe increment count. Okay, now the interesting thing is that we might get confused with this, why they have a count in their state and then they make us create another count. Okay, because, well, if we log in besides the count here, the store.getState is the same one because it's incremented with the action type add. Let's do the same all three, but now if we don't dispatch it type add, we only, I don't know, dispatch, does this work? No, we need to send something. Type of whatever. Okay, you can see now that our count increased because this method was called, but the store wasn't increased because we called another action. Makes sense for you? Let me know. So yeah, a good example what I would do is to console.log store.getState, like that. So don't increment something, we can just console.log the state, and then we can see, let's see, count is not defined. Where? But I'm not using count. What are you doing? Okay, so now you can see, let's add this back to add. Now you can see that we're logging the state, which is in my opinion better. So if our state would be an object with a count of 0, and here we're returning a new object with a count being state.count plus 1, and here we're returning the state, you can see now how nicely we have the entire state here logged out. Make sense? Okay, I guess this won't work now because I added extra code. And I didn't update that. Hey Sam, thank you. I will. Okay, and then I guess we can this and this to make it pretty. Alright, I went a little overboard with explaining, but hopefully it makes sense. Stretching time. All right. Combine multiple reducers. When the state of your app begins to grow more complex, it may be tempting to divide state into multiple places. Instead, remember the first principle of Redux. All app state is held in a single state object in the store. Therefore, Redux provides reducer composition as a solution for a complex state model. That sounds fancy. You define multiple reducers to handle different pieces of your application state. Then, compose these reducers together into one root reducer. The root reducer is then passed into the Redux createStore method. Okay. Reducers. So we have multiple reducers. Now this gets a little complex. Piyush, hi, welcome to the live stream. Okay, in order to let us combine multiple reducers together, Redux provides the combine reducers method. This method accepts an object as an argument in which you define properties which are associate keys to specific reducer functions. Okay. The name you give to the keys will be used by Redux as the name for the associated piece of state. Okay, I guess the out here is the out state and notes the node state. Typically, it is a good practice to create a reducer for each piece of application state when they are distinct or unique in some ways. Okay, hold on a second. Alright, sorry for the delay. Let's see. Typically, it is a good practice to create a reducer for each piece of application state when they are distinct or unique in some way. For example, in a note-taking app with user authentication, one reducer could handle authentication while another handles the text and notes that the user is submitting. For such an application, we might write the combine reducers method like this. Okay, so root reducer, combine reducers, auth, nodes. Alright, now the key nodes will contain all the state associated with our nodes and handled by our nodes reducer. This is how multiple reducers can be composed to manage more complex application state. In this example, the state held in the Redux Store will then be a single object containing out and nodes properties. Okay, so we'll have a big ass object. These are counter reducer. There are counter reducer which has state and takes action, increment to decrement. And we have out reducer, which logs in and logs out the user, setting the authenticated to true and false. Okay, so we have two reducers. Right, then our store will create a store with take the both reducers. Okay, so we need to create Redux that combine reducers, which will have now, let's see, count will be our count reducer and out will be our authentication reducer, like that. Okay, let's play around with our store. Console.log store get state. Okay, look at that. So even though we have two different states here in the reducers, in our store we have a big state. Let's see. I want to create a dispatch which will console log change, log state change. So this will console the log store get state. Okay, and I want store that subscribe. It was a log state change, something like that. Now, okay, go back a bit, put this here, and let's say initial state, like that. So, initial state. Let's not add the let's add a comma here so we can see the object. Okay, good. So now we have the initial state. We subscribed. Well, keep in mind that this is something I'm just playing around with to see how it works. Basically, this is how I'm learning. I take the code and change it and see what happens. Now we want to dispatch. Do we have actions? Yeah, we have a login action. We have increment actions. Okay, so let's dispatch a couple of actions. Store, dispatch. We want an action which keep in mind that needs, basically it's a function which return an object. So we can just pass in an object with a type of login. All right, look at that. So initially we have authenticated false, and now it's true. Let me put this on another row. Well, can I do this? Yeah, look at that, good. So this is our initial state, and now we have that. What if we dispatch a type of increment? Oh, I guess we can just call this here increment. Okay, so the count increases now. Okay, we can dispatch as many as we want, and all of them will change the state. And at the end, let's say we want to log out. Oops, log. Okay, this is nice. This is really nice. So we have a main state, and we keep changing what parts we want. All right. Nice. Let's see. Let's go to the next one. Let's see what else we can learn. By now you learned how to dispatch actions to the Redux store. But so far these actions have not contained any information other than a type. You can also send specific data along with your actions. In fact, this is very common because actions usually originate from some user interaction and tend to carry some data with them. The Redux store often needs to know about this data. Okay, let's see. There's a basic notes reducer and add note text, which I guess this is an action. Yeah, and add note text action creator defined in the code editor. Finish the body of the add note text function so that it returns an action object. The object should include a type with a value of add node, and also text property set to node data that's passed into the action creator. Alright, when you call the action creator, you'll pass in specific node information that you can access for the object. Okay, so basically here we want to return a object. If you remember, dispatch takes in this object, which requires a type. In this case will be add node, and we can pass something else. We can pass a text, which will be our node, right? So a text property set to node data that's passed into the action creator. When you call the action creator, you'll pass in specific. Okay, next, finish writing the switch statement in the nodes reducer. You need to add a case that handles add node text actions. We have only one action, so case add node, which will return, let's see, which needs to return something. This case should be triggered whenever there is an action of type add node, and it should return the text property on the incoming action as the new state. Okay, so we have a text here, initial state, and we want to change that. So we can just return action.text. Okay, and here you can see that it calls add node text with hello. We can later call it with yellow. And we need to get the state. Okay, so this might be a little confusing. The action is dispatch. Okay, so we have an initial state, which in this case is a string, although I guess the most time will be an object. This state is returned by default. Okay, but then we're creating an add node text action, which returns a type that will be used here in the switch statement. So basically we're calling this action, and in the switch we're saying, okay, what type of action did you send? Is it an add node? Okay, if it is, then we want to change our state to action type, the action text, which is sent here. Okay. But what I said, that initially you would have, usually you would have a state being an object like this with the property of text probably. So now here, instead of returning the text, you will return an object with a text. Oops. So something like that. We have text, initial state, text, but probably not always you'll have a state being an object. Who knows? Maybe sometimes you only have a number. Let me think. So yeah, maybe you want to keep track of a number in the state. Okay, so yeah. Let's go back to our first. Alright. Use middleware to handle asynchronous action. Okay, so now this is probably a little harder. Let's see what we have. Request data, receive data. We have two actions. One requests the data, the other one received, and we passed in the users. Okay. Then we're switching the action types. Return fetching true, fetching false, users an empty array. Okay, so this is a little fun. And we have apply middleware, Redux tank. Alright, let's see what they say about this. So far the challenges have avoided discussing asynchronous actions, but they are an unavoidable part of web development. At some point you'll need to call asynchronous endpoints in your Redux app. So how do you handle these types of requests? Redux provides middleware designed specifically for this purpose, called Redux Thunk middleware. Here's a brief description of how to use this with Redux. To include Redux Thunk middleware, you pass it as an argument to Redux apply middleware. This statement. Okay, so we create the store with the reducer, and okay, the second argument is this middleware. This statement is that provided as a second optional parameter to the createStore function. Take a look at the code at the bottom of the editor to see this. Okay, this one. Then to create an asynchronous action, you return a function in the action creator that takes dispatch as an argument. You return a function which takes dispatch as an argument. Ooh, dispatch is where? Then to create an asynchronous action, you return a function in the action creator that takes dispatch as an argument. Oh, I think this handle sync will return a function which, yeah, takes in the dispatch which will be passed in. Okay, this is a little complicated probably for some of us. Within this function, you can dispatch actions and perform a synchronous request. Okay, so we need this dispatch method if we want to call different actions. This example, an asynchronous request is simulated with a setTimeout call. It's common to dispatch an action before initiating any asynchronous behavior so that your application state knows that some data is being requested. This state could display a loading icon, for instance. Then once you receive the data, you dispatch another action which carries the data as a payload, allowing with the information. Okay. So basically, we dispatch an action before our asynchronous call, saying, okay, something is happening, something is loading. And then when the asynchronous call is finished, we will dispatch another action saying, okay, now I have your data, here it is. This is how I see it. Remember that you're passing dispatch as a parameter to this special action creator. This is what you'll use to dispatch your actions. You simply pass the action directly to dispatch and the middleware takes care of the rest. So this middleware this middleware will take care of our dispatch. But where handle where it is used? I don't see. Okay, let's see. Write both dispatches in the handle async action creator. Dispatch requesting data before setTimeout. So dispatch requesting data before setTimeout. Can we access the store here? Probably not. Maybe we can write store.subscribe, takes in a function, and console.log store.getState. I want to see the state. All right. Get state, but apparently it's not. Oh, maybe because we haven't used this. All right. dispatch requesting data before set timeout, requesting data, the simulated API call. Then after you receive the pretend data, dispatch request receive data. So here we want to dispatch received data. Oops, not that. And we're passing in the data. Okay, passing in this data. Now you know how to handle asynchronous actions in Redux. Everything else continues to behave as before. What? Where are we calling this handle async? That's interesting. They don't show us where to use this function. This is a what? Sort of. Okay. Let's go on and maybe they'll teach us in the next one. Write the counter with Redux. Okay, so they didn't. Okay, so that's a little confusing, right? Or only for me? Right. So write the counter with Redux. Now you've learned all the core principles of Redux. You've seen how to create actions and action creators, create a Redux store, dispatch your actions against the store, and design state updates with pure reducers. I think the most confusing part of Redux is all of these namings. I mean, we have actions, reducers, action creators, store, dispatch, reducers. Okay. Well, you've even seen how to manage complex state with reducer composition and handle asynchronous actions. We saw asynchronous actions, but we didn't see how it works. So, okay. These examples are simplistic, but these concepts are the core principles of Redux. If you understand them well, I don't, you're ready to start building your own Redux app. The next challenges cover some of the details regarding state immutability, but first, here is a review of everything you've learned so far. In this lesson, you'll implement a simple counter with Redux from scratch. The basics are provided in the code editor, but you'll have to fill in the details. Use the names that are provided. Okay. Once you finish, you should be able to dispatch increment or decrement actions to increment or decrement the state held in the store. Good luck building your first Redux app. Alright. Yeah, a lot of new terminology. Okay. So, increment and decrement. These will be our action types. So, increment and decrement. Now, the good part with something like this Redux is that if you want to use it in your app, I guess, you could work once to create some sort of boilerplate to have your actions and to define your store and all that, reducers. And then you can probably just copy and paste it around in other applications and it will be easier. So yeah, but still, if you want to understand it, I think you should create it from scratch a couple of times. Alright, counter reducer. Define the counter reducer, which will increment or decrement the state based on the actions it receives. Alright, so I already forgot what the reducer does. I guess it has a state which is 0 by default, and it takes action. Okay, and this will be a function which will return state by default and will have a switch case action.type. A case of increment will return state plus 1, and case of decrement will return state minus 1. And this is the default, so that should work. Inc action. So increment action will be a function which will return a type of increment. Decrement action will be a function which will return type of decrement. Like that. And the store will be Redux create store reducer, counter reducer. So I guess that's right. Now let's see, store.get state console.log. We have 0. All right. Let's make that thing. I like the subscription part. Store, subscribe. Also, you should subscribe if you haven't to this channel. Shameless plug. Okay, so subscribe takes in a function and we'll call console.log the store.get state. All right, so now every time we dispatch something, store.dispatch an action like increment action, okay, doesn't like something, or dispatch increment action. Okay, oh, so basically this should return an object, not be a block of code. So we need to wrap them around parentheses. Okay, so now you can see dispatch increment action creates 1, 2, 3, 4, 5, 5, like that. What we could do, well, I guess we could just say here count 0, and then we can return here count the state.count and count will be state.count minus 1. Okay, same. Let me write it nicely. This return a new object count like this, and decrement return count state new object, and this should be parentheses like this. All right, so now we're increasing the count property of our state. Increase, 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 and we can have decrease. Decrease, decrease, decrease. All right. I guess this is how you do it. Probably if we do it a couple more times, it will get easier and easier. We can also create a combine reducers, have multiple states. Okay, the Redux should be initialized with 0. Sure, let me remove this. State with 0. Okay, so apparently they don't like our object here. Okay, fine. State will be equal to 0. And then we just return state plus 1. If that's what you want, that's what you get. State minus 1. So now it should work. Okay, let's see. Never muted state. Good, so state with arrays. Alright, a little stretching. In an hour. We have a couple of more. Let's see. 4 more. Alright. These final challenges describe several methods of reinforcing the key principle of state immutability in Redux. Immutable state means that you never modify state directly. Instead, you return a new copy of the state. Okay, we learned about this in the JavaScript section, and I always suggest you do this. Instead of changing the array, just return a new copy of it with the changed values. If you took a snapshot of the state of a Redux app over time, you would see something like state 1, state 2, state 3, so on. And so where each state might be similar to the last, but each state is a distinct piece of data. This immutability, in fact, is what provides such features as time travel debugging that you may have heard about. I might have, but I haven't. Redux does not actively enforce state immutability in its store or reducers. That responsibility falls on the programmer. Fortunately, JavaScript provides several useful tools you can use to enforce the immutability of your state, whether it is a string, number, array, or object. Note that strings are numbers, and numbers are primitive values and are immutable by nature. In other words, 3 is always 3. You cannot change the value of the number 3. An array or object, however, is mutable. Mutable. That sounds like Pokemon. In practice, your state will probably consist of an array or object, as these are useful data structures for representing many types of information. There is a store and reducer in the code editor for managing to-do items. Finish writing the add to-do case in the reducer to append a new to-do to the state. There are a few ways to accomplish this with standard JavaScript or ES6. See if you can find a way to return a new array with the item from action.todo. Alright, so we have our state, which is an array of strings, and we want to add to-do, which probably will be a string. So what we can do here is that instead of saying state, instead of doing something like state.push action.todo, right? Action.todo, and then returning the state. This is not okay because we're mutating the array. Instead of that, let's use the fancy spread operator. We can spread the state, which is an array in this case, and then we can add the last item here, action that to do. And we're basically creating a new array, spreading the all the array's items and adding the last one. Hooray, it works. Use the spread operator. That's what we just did. Okay, so let's just do it again. I see they talk about push and stuff like that, so we just went through that. State and action that to do. And a comma. Semicolon, not a comma. Look at that, we went through 2 very fast. Remove an item from an array. Now this is nice. Because we want to remove something. How do we do that without mutating the array? Other useful JavaScript methods include slice and concat. Alrighty. We want to return again a new array. We're spreading the state, which is an array, but we need to keep track of the index. So we want basically to spread all the items in the array which are before the index and all the, well, before the element at index, at position of index, and we want to spread as the second, well, at the later part, all the elements which are after the index. Does it make sense? So in this case, let's see, we have 0, 1, 2, 3, 4, 5. Let's say we want to remove 1, which is the element at the index 1. So we're getting the array, only the first part, which is before the 1, and the second part, which is after the 1. We can do that with the slice method. So we're getting the state, and we're slicing or taking a part of it from 0 till action.index. We're getting the index here in the action creator. All right. So that's the first part, and the second part will be to spread. Basically, this will be an array, so we're spreading the items from it. The second part will be state.slice from index +1, so we want to go to the next element to the right of the index till the end, so we don't need to provide another argument to the slice function. Now I want to see this in action, so what we're going to do, store.scribe function, which will console.log our store, store.getStore. And now we want to see how to remove an item. So store dispatch remove item, and we need to pass in an item. Let's say the index of 1. Index is not defined. Remove item, we passed in the index, subscription, index. Okay, so I said index here, but actually is action.index. And let me put this nicely on 2 lines so you can see that we have an array. In the first part, we're spreading first what is the left from the index, and the second part what is the right. My name is Florin. Shish. Thanks for asking. Okay, store.get state, not store, get state. Okay, so now you can see that, well, we need one of these calls before, so we can see the initial state. This is the initial state, then we're dispatching remove item 1, so we remove the item at the index 1, and look at that, how nicely we have a new array without the 1. Okay, let's remove this code because apparently they don't like it. Alright, and the last one, copy an object with object.assign. Alright, sure, we can do that, or we could just spread the object. The last several challenges work with arrays, but there are ways to enforce immutability when state is an object. A useful tool for handling this is object.assign. Object.assign, it takes in the first what object you want to use as a base object, and then what you want to put inside. This creates new object as a new object which contains the properties that currently exist in object 1 and object 2. Now in ES6, I think ES6, or was it later, I'm not sure, we have spread on objects also. So what we did for arrays, we can do the same for objects. Redux state, okay, actions were modified to handle an object. So we have the state being an object with properties. Edit the code to return a new state object for actions with type online, which is set the status property to the string online. So we have the state. Okay. So what we want here is to return a new object. We're spreading the state, which is our state object, and we want to set the status property to online. Okay, and this will work. We can also use object.assign, which will basically be something like return object.assign to a new object. We want our state, and we want another object which has the status be online. So this will merge, and the status will override the state status. But yeah, look at that, how this looks compared to this. Thanks to ES6 or whatever version it was, we can just use this magic 3 dots and everything should be okay. We are forced to use it. Object.assign. Alright. And we are done. Look at that, we learned about Redux. Now my only concern is that even though we looked into asynchronous code here, we haven't used this handle async function. So I don't know where do you put it. Well, I guess that's a something we should I look it up online? Let's see. Redux synchronous example. Let's see, we have that. So we have our types, action types, okay. Action.js, return, right, so return our actions. Handling actions. Alright, post, switch, combine reducer, async action. Okay, this is what I want. So function return. Okay, fetch post. This returns our dispatch, which dispatches our action, and it returns a fetch to then blah blah blah. Okay. Alright, we're storing the response from the API, and then in another then we're dispatching receive props. But where are we going to use fetch props? That's what I want to see. Fetch props. Oh, so this is just an action creator. You can see here fetch props. Let me zoom in. So fetch props, which is this asynchronous whatever, is fetched, is used as a dispatch. Alright. Okay. So basically this will go inside of a dispatch. So let's do that. Store dispatch handle async. Now, in order to test it, we want to store scribe channel. Then we want to console.log store.get state. Get. Now we also want to dispatch this bad boy. Dispatch requesting data here. Alright, and we're going to dispatch. Basically, we did this part for the receive data. Users cannot find users of undefined. But oh, we need to pass in users here. So you can see that we're fetching And undefined. Oh, data. Sorry. And we also have our initial state. So this is initial state. Fetching is false. We don't have users. Then fetching is true because we dispatch this handle sync. And then fetching is basically, in this case, you would show something like a loader, waiting, getting the users, and then fetching back to false, and we have the users. All right, good. See, Google is our best friend when you want to learn something. Well, when you want to learn something quickly, like a really specific thing. Okay, guys and girls. I hope this was useful for you. I relearned Redux. I feel like I understand better now, which is great. And in the next section, we're going to learn, I think, how to apply Redux in our React application. And then later today, we're going to start to work on some cool projects. Joey says that he's getting the concepts. Yeah, I find it more interesting now. Yeah, go over the concepts again, do it on your own, read it, and it will get better. Oh, I had issues getting the okay then. Well, yeah, go over it again and see how it works. Probably the best way will be if you actually did something with these examples. All right. Thanks for watching. If you enjoyed, give this video a like. If you didn't, give it a dislike, whatever, so I know that you didn't like it. And let me know why you didn't. And I'll see you in the next live stream. For those of you who are watching, that will be pretty soon. For those who are watching the recording, as always, go to the description. You'll find a playlist with all of the sections. In the meantime, take care and happy coding!